Hello, I am Vishal Vasistha, Assistant Professor, IIMT College of Engineering, Greater Noida. I am going to discuss on geothermal energy. Geo means inside the earth. Thermal is related with the heat. So, if we are going to extract energy from inside the earth, so that energy will be considered as geothermal energy. So, these will be contents: the sources of geothermal energy, geothermal power plants, comparison between geothermal and conventional thermal power plant, non-electrical applications of geothermal energy, advantage and disadvantage of geothermal energy, materials and site selection criteria, environmental problems, and potential of geothermal energy in India. So resources of geothermal energy. Hydrothermal resource. It is also known as geopressured. So there are hydrothermal, geopressured, hot dry rock, active volcanic vents, and magma. So these all are the hydrothermal resources of geothermal energy. So hydrothermal, hydro means water, thermal means heat. So we are extracting heat from the water that is inside the earth. So water is hot, so we are getting energy from the water, and that energy is used to generate electricity. So hydrothermal resources contain superheated water or steam. So superheated steam that is having temperature higher than 100 degrees centigrade, it's more than 200 degrees centigrade. You can see the temperature range 100 to 240 degrees centigrade. So above 100 degree, that is coming under superheated steam. So superheated steam is having a lot of energy. So that energy will be extracted in the form of electricity or other uses. So to use this hydrothermal energy from superheated water or steam that is available inside the earth, wells have to be drilled to reach that hydrothermal reservoir. Here you can see in the diagram, magma, it's also at very high temperature. So heat is always from the magma. Heat, it's in vaporized form, so it's going to be raised. And this is the hydrothermal reservoir. So we have to reach to the hydrothermal reservoir. So hydrothermal reservoir, to reach the hydrothermal reservoir, we have to bore well, and from that well, heat will be reached on the ground, where this heat can be utilized as an energy resource. Now geopressure. So geopressured resource is hot water or brine trapped underground. So geopressured, from the name itself, we can identify geo inside the earth and pressured. It's because this hot water is at high pressure. So that's why it has been termed as geopressure. So this geopressured resource using hot water, it's found at about 2400 to 9100 meter. So it's approached at 2.5 kilometer to 9 kilometer, and temperature is lesser than the superheated geothermal resource, that is 160 degree centigrade, and pressure of water is about 1000 bar. So from here you can identify that 1000 bar, it's too much pressure is there. So that's why this is termed as geopressure, because of the higher pressure range of hot water inside the earth. So it's available at high pressure, so obviously we'll be getting higher energy. But it's uneconomical because of the low temperature. Superheated water is having high temperature, so at high temperature we'll be getting higher energy. So temperature is low. So obviously we have to drill hole, so that hole, so their costing will be there. So if by putting that cost we are not able to extract sufficient energy, then that is going to be no use for us. So it will be uneconomical due to low temperature, and obviously cost will be higher. Why there will be high cost of digging? Because you can see the depth of the geopressure underground water. It's 2.5 kilometer to about 9 kilometer. So 9 kilometer drill a hole, obviously it will be having a higher cost. And after getting that cost, temperature is 160 degrees centigrade. So we won't be able to get sufficient energy. So that's why it's uneconomical, and that's why it is used less. Now hot dry rocks. By the name itself, we can identify that this rock is hot, so the temperature is higher, but it's dry. So there should be steam mainly. Water will not be there. So that's why. So at higher temperature, water is converted into steam. And if that temperature is further higher, then that steam will be converted into supercritical steam. So here we can see high temperature rocks are available. So those and the temperature range is 90 to 650 degrees centigrade. So here we can see that temperature range is at higher side. Superheated steam was having temperature till 240 degrees centigrade, but hot dry rock temperature goes up to 650 degrees centigrade. So if rocks are at this much temperature, so if water is passing through between these rocks, so obviously that will be converted into superheated steam and temperature will be very much higher. So the water will be circulated through these rocks to extract thermal energy. Then active volcanic vents. So there are so many volcanoes. From volcanoes, higher temperature heat is coming out of those vents. So that should be utilized. Otherwise, that's going to be wasted. So that is these volcanoes are also a huge source of energy if that can be used. But obviously, it will be difficult to reach that volcano because of very high temperature range. You can see temperature range is 700 to 1600 degrees centigrade. So 1600 degrees centigrade temperature, so obviously it will be difficult to reach. So obviously to extract thermal energy, it's going to be tough. But if somehow we are able to get that energy, so obviously because of high temperature range, energy also will be of sufficient level. So that energy can be utilized to generate electricity of high voltage and high current. So active volcanoes are worldwide available. Because of high temperature is, it's difficult to approach them. But if it's going to be possible, then it's a huge source of thermal energy compared to other geothermal resources. So research is going on that. Then magma. Magma is present at shallow depth at certain places. So this magma, it's actually boiling liquid. So from magma, it's also having higher temperature. But at that depth, we have to drill the hole. So that will be costlier. But if we are able to reach that place, so much heat will be extracted and can be utilized that geothermal energy. Now hot springs. So these hot springs are uh, visiting places worldwide. Many visitors are approaching these hot springs. Many are most familiar. So these hot springs, except or rather than the visiting places, uh, those can be used as a geothermal energy resource. So there are many popular hot springs are available. Those are very popular places like Iceland, New Zealand, Chile, Japan. These places have so many hot springs. So these hot springs should be utilized to extract the energy because from the hot springs, here you can see the diagram. It's hot water is there. and continuously because of high temperature, it's going to convert it to steam. So this is superheated steam. It's directly released into the atmosphere. So energy is not utilized here. If this energy can be utilized, so obviously we can extract energy, and that energy can be utilized in terms of electricity, or can be used for other purposes. So heat of molten rock. The earth is pushed up through fault cracks near earth's surface within 2 to 5 kilometers. So actually in these hot springs, this hot water or superheated steam is coming out from inside the earth from 2 to 5 kilometers. So it's by the nature itself. These hot springs are available worldwide. So hot water and steam are violently and periodically ejected. In some hot springs, uh, these, this hot water and steam is continuously coming out, and sometimes it's coming periodically, like that volcano. Some volcanoes are always active, some are sometimes those are not active. They are active periodically. There is a particular specific time. At that time, those volcanoes are erupted. So similarly, these hot springs also. So if those are continuously, these hot springs are at their level continue, then obviously we will be getting sufficient energy all the time. So that should be utilized, and I think that is the need of that is the need of, because of the limited source of renewable, and these renewable sources are taking a lot of time. They have taken millions of years to be formed, and nowadays because of Earth population is going to increase day by day, so those are going to be consumed, and because those are taking a longer time to reform, so obviously it will take. So there is difference between their formation and their utilization. So if utilization is going to increase, so we have to move on towards renewable sources, the non-conventional sources. So the geothermal energy reservoirs, or this geothermal energy resource, uh, could be a great impactful if it can be used. So it has not been explored at that much level. It's having capability. So researchers should think uh, over it, and some pilot plants have been placed even in India at many places like in Himachal, Gujarat. Some places pilot plants have been set up to check their feasibility and their capability, so that further this the pilot plant can be explored in the form of main plant, and more energy can be extracted, and it could be better for world if we can explore the renewable sources of energy. So when water percolates, it's heated as it comes in contact with the hot rocks. So actually, geothermal energy is in the form of hot water, as well as magma is there. Magma is inside core. It's available all the time, and from magma superheated steam is coming out, and that is making making rocks hot. And if fluid is passed through these hot rocks, so that will be converted into superheated steam. So that steam uh, can be utilized. Similarly, as Rankine cycle, we are using where boilers where water is boiled in boilers, and we are rotating the turbine, and we are getting electricity uh, by placing generator on the turbine shaft. So in the similar way, this geothermal energy can be utilized to run the turbine to generate the electricity, and that is the need of the world nowadays. So, but at the same time, whatever water is coming out of the water stream, so obviously that is coming naturally, so that will be having certain mud and clay. So to remove that one, a filter has to be placed if we are planning for a pilot plant, and further to explore that one. So that will be coming in the further slides as a part of the part of the geothermal power. Steam ejector, high temperature near magma may cause water to boil and transform into superheated steam. So if there is superheated steam and it's having higher temperature, so obviously we will be able to release or extract sufficient amount of energy. That is need. So renewable sources should be utilized as much as possible. So steam ejects out through vents, and that can be termed will be termed as steam ejector. Now we are coming to the geothermal power plants, that how they are looks like. So you will see that this upper part where steam is coming and it's going to turbine, it's rotating the turbine shaft, and where generator is connected, we are getting the electricity. That is also the part of the thermal power station. So here only what is the difference there, that we have the production well from which we are extracting the energy. We are extracting the superheated steam. So this steam obviously it's coming inside from the earth. So obviously it will be having certain dust particles, some rock particles, some hot, so clay particles will be there. So obviously those has to be separated, because if those are not separated, so those will be coming into the turbine bed. So they may damage turbine beds, and obviously if turbine will be damaged. So we won't be getting the extract energy. So for that purpose, centrifugal separator is used. So centrifugal separator will be acting on the principle of centrifugation. So in centrifugation, it, it will be rotated. Whatever separated steam we are getting, so all these will be it will be rotated by the centrifugal action force, and all will be settled down. All impurities, mud, clay, these will be settled down, and those will be solid metal. So those will be taken out from the main stream. So after this, there will be a dry stream. It's dry stream because it's from the production well. It's coming superheated steam. So it's a dry stream, not having any water, and obviously water should not be there, because otherwise water may corrode the turbine blades, and that is not required. That is not so. To to improve the durability of turbine and to make the system or plant more efficient, so we have to use dry steam. So because of using that this dry steam, this power plant has been termed as vapor dominated. Vapor dominated because there is dry steam. If it will be water dominated plant, so obviously there will be water vapor also inside there will be moisture. But here it's vapor dominated, so there is dry stream, and after when turbine is rotated and we are getting the electricity, it's going to condenser and from the cooling tower, and remaining one it's going again. So this cycle is continuously going on. So here we can see for water dominated plant, pressure of the steam is 7 bar, about 7 bar, and temperature is about 165 degree centigrade. So 165 degree centigrade is so there. So we will be able to we will not be able to get that much sufficient amount of energy, because we need high temperature of this vapor coming out from the inside the earth. Dry steam fields are located at the eastern region of California, USA, then Italy, and then some region of Japan. So worldwide, so it has been explored much. It has been explored much at international level. But in India, government also has have been set up some pilot plants, and I think from my point of view, it has to be explored at a great level, because it has a sufficient amount of energy. A sufficient amount of energy, and worldwide there are many volcanoes also. So if it could be possible to reach those volcanoes, so obviously 1600 degrees centigrade. So you can think that how much energy those volcano erupt streams have. So that should be utilized. So it would be impacting a great level of energy, and it would be a sufficient and high part of the renewable energy. So then this vapor dominated well, whatever we have studied, it's having part as production well, centrifugal separator, then turbine, and then condenser has to be there to condense the steam. Again, it will be converted into water, and that will be going to cooling water. So it's a simple cycle that is used in thermal power stations. The Rankine cycle uses the same Rankine cycle, only the source has been changed. in thermal power plants, the the source is the coal. Mainly the coal is the source, and here it is a renewable source of energy. So coal is conventional source of energy, so that is limited. So we have to think for, and we should try to utilize renewable sources of energy as possible. Then liquid dominated high temperature plants. So if by the name itself it's showing liquid dominated, so there will be wet steam. So here you can see production well, wet steam is coming, and then this wet steam will be converted into dry steam, because we don't want wet steam inside the turbine. All other operations are similar, but here you can see temperature is 250 degrees centigrade. So obviously this liquid dominated plant, because of this temperature is 250 degrees centigrade, it's known as high temperature plant. So if temperature is higher, so obviously we'll be getting higher energy. So in Japan, there is 50 megawatt HO1 plant is there. So at international level, it has been explored more. So many plants are there. 50 megawatt plant is there. So obviously it's high capacity plant using geothermal sources. Now there is one more type of plant, double flash steam system. It's known as double flash because here you can see two flash evaporators. In two stages, wet steam is converted into dry steam. So this dry steam, if it's from the first flash evaporator, it won't be having that much pressure. So obviously it will be passed through low pressure turbine. After passing to second flash evaporator, second stage, it will be having high pressure, so it will be passed through high pressure turbine. So according to this diagram, because there are two flash evaporators to fulfill the need, there are two turbines, so it's known as binary cycle because all are used in. Now hot dry rock. So in hot dry rock, you can see reservoirs are made, are man-made. Some reservoirs are naturally there. So from the naturally energy can be extracted, or some reservoirs can be prepared by the man for a specific purpose to situate a plant on the ground at the geothermal site. So from man-made reservoirs, its injection well, all as well as here. So here you can see heat exchanger is there. So this heat exchanger, purpose of the heat exchanger to transfer the heat from one fluid to another fluid. So here you can see from this hot water, it's going to be pumped so that it's continuously reaching to heat exchanger. So here you can see there are two cycles. One cycle is this one from production well. Hot water is going converted into steam, and then again it's going to water and it's going. So one cycle, and from here you can see heat is transferred to the another cycle. From that cycle, we are generating the electricity. Now, difference between geothermal power plant and conventional thermal plants. So there are certain advantages and disadvantages with the geothermal and thermal power plants. In thermal power plant, efficiency is 40%, geothermal efficiency is 15%. But if we are not using geothermal power plant, so that geothermal energy is going to be wasted. So if efficiency is lower, even after that, if we are able to use, then it will be better for us. Like solar power plants. So solar plants are also not having efficiency greater than the 25% about, but that is very popular and used. Then there are many applications of geothermal energy to cure eye and skin disease, for space and water heating, for chemical and textile industries, for crop drying washing, for fish culture. And there are certain advantages and disadvantages of geothermal energy. So obviously it's reliable source, it's renewable, so it's available in a huge quantity. Small space is required to install the plant because it's only limited with the geothermal site. Does not require any fuel, but disadvantages that it's low grade heat, so temperature is low. If the at geothermal site we are not getting high temperature, at geothermal site we are not getting high temperature, so obviously we will not be able to get sufficient amount of energy. So for that we have to select the site where temperature of geothermal energy hot water is at higher range. What are the materials required for geothermal plant equipments? So materials should be selected on the basis of, because there are many foreign particles available in the geothermal hot water or superheated steam. H2S, NH3, CH4, CO2, H2, and there are many solid particles. So those has to, so we have to consider material for geothermal plant equipments on the basis of this, because hydrothermal fluids are corrosive and abrasive in nature. So material should be according to that. So those materials are carbon steel, stainless steel, platinum and gold rhodium, tin, aluminum, stainless steel. There are certain environmental problems because many unwanted gases are coming out. Those are toxic gases. Those are polluting environment as well as those will be affecting the human beings. Those are corrosive and toxic. So to select the geothermal site, we have to we have to consider these factors. Drilling should be easy, cost should be as minimum as possible. Geothermal energy should be sufficient so that we can get adequate power capacity. Otherwise, there will be huge investment and we won't be getting sufficient energy, so that will be of no use. And it should be near the load sector to reduce the cost of transmission. Because at the geothermal site, if villages or some cities are there, so obviously transmission cost should not be that much high. There is a huge potential of geothermal energy in India. Still, it's in initial phase. Some pilot plants have been set up, but there is a need to set up main plants. So here you can see some in Himachal Pradesh, in Jammu and Kashmir, even 10,000 megawatt plants have been proposed. So to propose these plants, still proper and detailed investigation is required. So here you can see there are many potential sites, some in Himalayas, Haryana, Gujarat West Coast, Sonanamata Tap, Godavari, Mahanadi. So there are many locations, there are many potential sites. Those are creating energy of higher level. So our government is planning and they are working more, and I think more detailed investigation is required. Some pilot plants already have been set up, and after their result and careful investigation, main plants can be. Thank you very much. Thank you.